Hi students, in this video we are going to discuss about gravitational potential energy. Now before going to this topic, let us discuss what is gravitational field. I hope all of you are familiar with the term magnetic field. You have studied about magnets in 10th standard. So magnetic field, what is a magnetic field? If you have a magnet and you bring a nail, so if you place the nail somewhere close to the magnet, definitely the magnet will attract the iron nail. But if the nail is kept far away from the magnet, will it attract? Definitely no. Why? Because each magnet is having a region around it where the force of the magnet can be experienced by the object placed there. Similarly, we all know every object in the universe attracts each other with the force of attraction. It is known by the name gravitational force. So which means every object is having a region around it where the gravitational force can be experienced by another object placed there, and this field is what we call gravitational field. So gravitational field, it is a region around an object where the gravitational force of attraction can be experienced. Now if you take the case of Earth is also having a gravitational field, and any object which is placed within this gravitational field of Earth will be attracted towards the center of the Earth. So now we are going to derive an expression for gravitational potential energy. So what is gravitational potential energy? We understood what is gravitational field. It is a region around the object where the gravitational force can be experienced by another object placed there. So what is gravitational potential energy? Now if there are two objects which are placed at a particular distance, definitely there will be a force of attraction between them. So there is a force, or it possesses a kind of potential energy. Now if you take an object, that object will be having a region around it where the field or force of attraction can be experienced, and I have kept another object close to it. Now if I want to take this object away from the gravitational field of the first object, what I have to do? I have to do some work. Similarly, if I want to bring an object from a distance to the field of another, also I have to do some work, which means some work has to be done, and this work is stored as potential energy. In our case, it is known as gravitational potential energy. So gravitational potential energy is defined as amount of work done in bringing an object from a farther place. We consider it as infinity, from infinity to a point in the gravitational field of another object. So it is the amount of work done in bringing an object from infinity, from a faraway point, to the field of another object. So let us derive the expression for gravitational potential energy. For that, we consider Earth to be a sphere, perfect sphere of mass m and radius r. This line denotes the center portion of the Earth. Okay, this is the center of the Earth. Okay, and r is the distance from the center of the Earth to the surface. Now imagine a point P. Okay, this point is at a distance small letter r from the center of the Earth. Point P is at a distance small letter r from the center of the Earth. and we wish to find out what is the value of gravitational potential energy at point P. For that, what we do is we consider another point A. Okay, now this point A is at a distance x from the center of the earth. So now we have point P and point A. Point P is at a distance small at r from the center of the earth, and A is at a distance x from the center of the earth, where we assume the object is placed. Object of mass m, small at m, is placed. Okay, and what we do is from point A to a point B, which is at a distance dx from A, I am going to move the object, which means I am going to do some work. I am going to find out what is the amount of work done in displacing the object from point A to point B. So I got the small amount of work done. But what is my aim? My aim is to bring my object actually from infinity to point P, to find out what is the potential energy there. So we got the small amount of work done in bringing the object from point A to point B. Then how will we find out total work done? Yes, we integrate. We integrate from infinity to point of observation, that is P, and find out the total work done. This is the steps which we are going to do. Okay. So first, we imagine the object is placed at point A. So the gravitational force of attraction between the object of mass small letter m at point A and earth of mass capital M is given by F is equal to g m by distance from the center of the earth to point A is x, so divided by x square. This equation 1. Now what is my next step? I am going to move the object from point A to point B. For that, I am going to do a small amount of work. So amount of work done in bringing the object from point A to point B, which is at a distance dx from A, is, you know, the equation for finding out the work done is W is equal to F dot S. In our case, the object force of attraction is towards the center. Object is also being moved from in the same direction, which means theta is equal to 0 degree. Hence, we can write W is equal to Fs. In our case, it is what? Small amount of work done. So dW is equal to F dx, since theta is equal to 0 degree. Now we are going to substitute the value of F from equation 1. So from equation 1 we get dW is equal to g m divided by x square dx. So I got what is the amount of work done for moving the body through a small distance dx from point A to point B. But what is my aim? My aim is to find out what is the amount of work done in bringing the body from infinity to point P. Now where is point P situated? Point P is situated actually at a distance small letter r from the center of the earth. So therefore, total work done in bringing the object from infinity, that is x equal to infinity, to point P, that is x is equal to r, is W is equal to integral from where is my initial point? The object is now at infinity, so initial point is infinity to where I am bringing to point P at a distance r. So integral from infinity to r dw, which is equal to integral from infinity to r g m by x square dx, which means we are integrating with respect to x, the distance. So we know capital letter G, small letter m and capital letter M are all constants, so we can bring it outside the integral sign. We get W is equal to GMM integral of 1 by x square dx, the limit infinity to r. And what is integral of x raised to n dx equation? This x raised to n plus 1 by n plus 1. So we get integral of 1 by x square dx is equal to x raised to minus 1 by minus 1, which can be written as GMM by minus 1 by x, the limit infinity to r. Now how will we apply the limit? It is always upper limit minus lower limit. So the equation can be written as W is equal to GMM into upper limit, that is 1 by, instead of x what we have to do? We have to write r minus 1 by lower limit, that is infinity. Now any number by infinity is 0, so this term becomes 0. We get the final equation as W is equal to minus GMM divided by r, and this work is stored as potential energy. So we can write gravitational potential energy U is equal to minus GMM divided by r. This is the equation to find out gravitational potential energy of an object placed at a particular point in the field of the other. Now if you look in this equation, there is a negative sign here, isn't it? And the negative sign indicates that gravitational potential energy is due to the attraction between objects. So we can say gravitational potential energy is attractive. Okay. So what we did? First we kept an object, our aim is to find out the potential energy at point P. For that we kept an object at point A. We found out what is the amount of work done in bringing the object from point A to point B. We got dW. Then to find out the total work done in bringing the object from infinity to the particular point P, what we did is we did integration, and we got the equation as of gravitational potential energy as G is equal to minus GMM by R square. Sorry, GMM by R. Next, we are going to see what is gravitational potential. Actually, there is a slight variation in the definition of gravitational potential energy and gravitational potential. And it is denoted by the letter B. Now, gravitational potential is defined as the amount of work done in bringing a unit mass, the body having unit mass. That is the difference. Unit mass, in bringing a unit mass from infinity to the point. Other one was the amount of work done in bringing a body from infinity to a point, but gravitational potential is amount of work done in bringing a body having unit mass from infinity to a point, and is denoted by V is equal to work done by U m. Now, the equation to find for work done in bringing an object from infinity is W is equal to minus G m divided by R. So, substituting the value of W in the above equation, we get V is equal to minus G m by R by G m by R divided by m. So, we get V is equal to minus G capital M by small letter r. This is the equation to find the gravitational potential. So, next we are going to write the relation between gravitational potential energy and gravitational potential. That is relation between U and V. We know the equation for gravitational potential energy is U is equal to minus G mm by R. And equation to find gravitational potential is V is equal to minus Gm by R. So, if we compare the above two equations, we can write gravitational potential energy U is equal to gravitational potential into mass of the object. U is equal to V into m.